Hi students, hope everyone is fine and safe. It gives me immense pleasure to welcome you all to my new video, and today's video is about another interesting topic in 8051 microcontroller. We're going to see timer programming in 8051. We're going to see how to configure or how to program the timer in this particular video, right? And before watching this video, I would recommend you to see the previous videos of timer so that you can understand the basic operation of timers, what are the different modes of operation, how we can configure a timer into a timer or a counter, right? What is TMOD and TCON register, right? So today we will start with timer programming, right? And as I said before seeing this timer programming, you have to understand what is TMOD register and TCON register. I'll just quickly refresh that. We know that whenever we want to configure a timer, that is, we know that timer will work as a timer and as well as counter, right? If timer is using the internal clock pulse, it is used as a timer, and if it is using the external clock pulse, it can be used as a counter, correct? Right? And I have already explained this TMOD register, but before programming, once again I'll explain. These two bits tells you what is the mode of operation that we have to work, right? And we know that we have four different modes: mode 0, mode 1, mode 2, mode 3, and I have already explained how these modes works in previous video, right? And this bit, we know the importance of this bit, C by T, that will tell you whether it is working as a timer or a counter. When C by T is equal to 0, it is working as a timer. In C by T is equal to 1, it will work as a counter, right? And you know what is the operation of gate, right? Whenever we use an external clock pulse, we have this gate, right? And for counter operation, this gate will be 1, right? And it will be cleared for timer operation, it will be 0, correct? All these things we have already seen, right? And similarly, there is another important register which is TCON register, which controls the timing operations, right? As I said, which timer we have to select, which overflow will happen, all these things will be controlled by the TCON register, right? And I have already explained this, but once again I'll just refresh this particular register. You can see here we know that there is timer 0 and timer 1, right? So timer 0, that is TR0 and TR1, that represent timer run bit. If timer 0 is enabled, then this bit has to be 1, right? If timer 1 is enabled, then this bit has to be 1, right? Understand very clearly, right? So that you can able to configure the timer. Right now, if we want to enable the timer 0, then all the bits has to be 0. This bit alone must be 1, right? Which means the timer 0, timer run bit 0 is 1, which indicates that timer 0 is on, right? And similarly, when this is timer run bit and this timer run bit of timer 1, right? Similarly, when this is enabled, right, you can see TF0 and TF1, right? TF0 is nothing but the interrupt flag, that is overflow flag, timer overflow flag, right? We know that in every modes, whenever the timer overflows, it will enable the TF flag, correct? Right. So similarly here, it can be TF0 and this is TF1, right? So if you are using timer 0, after overflow, what will happen? This bit will be enabled, right? If you are using timer 1, then after overflow, this will be enabled, correct? And these two, right? This one, IE1 and IE0. This is nothing but the external interrupt. I already said what is external interrupt. When there is an external interrupt, that is INT0 and INT1, right? Whenever timer 0 uses the external interrupt, this one, and timer 1 uses this one, correct? This is external interrupt. And what about these two? I already explained this. These two will tell, we know that these two are external interrupt, right? And these two modes, these two bits tell you how this external interrupt will happen, whether it happens at the negative edge trigger or at level edge trigger. Sir, what is negative edge? What is level edge trigger? Right? That is when the very interrupt is happening, when there is a transition from higher level to lower level, then that is called as negative edge trigger. Right? When there is a transition from higher level to lower level and the interrupt happens, then that is called as negative edge trigger. And similarly, when there is a lower level, right, when the interrupt happens at the lower level, then that is called as lower level triggered interrupt, right? So whether the interrupt, external interrupt is lower edge triggered or negative edge triggered, that will be indicated by these two bits, right? I have explained all these things before, right? Now for programming, right, you have to understand that you have to configure these two registers to make the timer work perfectly, right? So you can see this is bit 0 1 2 3 4 5 6 7. You have to know the numbers of each and every bit, which is tr0, which is tr1, all those things. Similarly, you have to know the numbers of these bits, these bits. Okay, right? Now we'll start the program, right? And before starting the program, we know the timer will overflow whenever it reaches this FFFH, right? And we need to feed the count value. When you, as I said before, right? Whenever we need to start the timer, what we will do, in order to start the timer, we have to make TR0 bit 1 or TR1 bit 1, right? So it will start the timer. But before that, what we have to do is we have to give the count value for the timer so that it will start from that particular value, right? So to find out the count value, right? To find out the count value, there is a formula where this is the formula for that count value. You can see here FFFFH minus value plus 1. Whatever value we are trying to give, right? That has to be subtracted from this maximum value, right? And you have to plus 1 so that we will be able to get the count value so that we can able to program the timer, right? And you can see a good example here. If the count value is 9, right, what we have to do is I have to subtract this 9 from this FFFFH plus 1. What will give you? I will get this particular value, right? If this is the value, what I can do is these two bits are lower bits and these two are higher bits, right? We know that how to represent lower bits and how to represent higher bits. So TH0, you can see here TH0 is nothing but FF1, right? FF, and F7 is nothing but I'm saving it in lower bit, right? So TH is nothing but higher bit, right? And TL is nothing but lower bit, timer lower bit, right? And 0 represents I'm using timer 0 higher bit, I am using timer 0 lower bit, right? So this is how you have to determine the count value, right? So for any program using timers, you have to understand these basic thing, right? When my timer will work as a timer, right? What is the value of C by T? By that, you can able to find out whether it is working as a timer or counter. And then I have to configure T mod and T count register, right? Provided we have to give the count value. This is the basic for all the programming for timers in 8051, right? Now we'll see the program. Now you can see here the program is write a program to generate 20 microsecond, right, delay. That is, I'm going to use delay, right? Send logic 1 to port 2.0. I have to send logic 1 after creating the delay. What I have to do is I have to send logic 1 to this particular pin, right? And they have given the oscillator frequency as 12, right? And remember one thing, whenever we need to find out the count value, right, the one count value, right, what we have to do is we have to divide 12 divided by the oscillator, given oscillator frequency, right? So normally in order to find out the clock frequency, what we will do is we will divide the oscillator frequency divided by 12. Here to determine the count, what we have to do is we have to find out 12 divided by this 12 again, right? So for determining the count, right, what we have to do is we have to divide this particular 12 by the oscillator frequency, right? That is the very first thing, right? Now we will see how to configure tmod and tcon register so that it can produce the 20 microsecond, right? First thing what I have to do is I already said that whenever we write program, what we will do is we will use mode 1 because that is the mode where we will have maximum delay, right? And now what first thing is what we have to do is we have to select the mode which we are going to work, right? What is the mode? We know that 0 0, 0 1, 1 0 and 1 1. This is mode 0, mode 1, mode 2 and mode 3, right? So for mode 1 what I have to do, I have to make it as 0 and 1, right? So now understand that I'm going to use a timer 0. I'm going to use timer 0, right? So first we will have to configure the tmod register, right? I'm going to configure tmod register. Just listen very carefully. Now I know that I'm going to use timer 0. So I'm going to use only these bits, right? I'm least bothered about these bits, right? Because I've determined that I'm going to use only timer 0. So now how can I configure this particular bit, right? This particular tmod register, this bit 1 2 3 4 will be 0 because I'm not bothered about that particular bit, right? Now I'm bothered about these 4 pins because I'm going to use only timer 0, right? And now we got to understand what is gate and what is C by T, right? And now what is C by T? C by T tell you when it is using as a timer or a counter, right? Now what we are doing is we have to generate a delay. Whenever the timer works as a delay, right? That is whenever you need to generate a delay, then it will work as a timer because only if it is using the internal clock cycle, you can able to count the internal clock cycle and we can able to produce the delay, right? Whenever it is working as a counter, right, it will counts the values, right? It counts the number of operation that is done executed outside the microprocessor, right? And here microcontroller, sorry. So you can see here now I'm configuring it as a timer. So now what will happen? The C by T will be 0, right? And if it is timer, then gate value is also will be 0. We know that, right? Whenever we produce external clock pulse, only then this gate will be 1, right? And now what I have to do, I have to enable in mode 1, right? So what I can do is I can put 0 1 because that is mode 1, right? And now we know that for timer 0, this is what I'm going to use. This B represent the memory location, right? This is for timer 0, right? This is how I have to configure the tmod register. You can see now how we obtain tmod register. This is the value, right? And after configuring tmod register, now what I have to do, I have to go and enable the tcon register, right? You know that what is tcon register? Tcon register will tell you which timer is going to work, right? Obviously we have selected timer 0. So if timer 0 is selected, then what we have to do, this pin TR0, this has to be 1, right? This has to be 1. So which tells you that if I want to start the timer 0, then only this pin has to be enabled, then all the other pins has to be 0. All the other pins has to be 0. You can see here, this is the timer 0. We are setting the timer 0, right? That is, we are starting the timer 0. And whenever we need to stop this timer, what we have to do, we have to make this bit 0. We have to make this bit 0, right? So you can see here, whenever we want to stop the timer, everything will become 0. Now clear? These three information is same for almost all the program, right? For almost all the program, if you want, you can change it to timer 1. But if not, you can always configure timer 0 and mode 1. Mode 1 has to be selected by default, right? And now what is the next step? I said we have configured the timer, tmod register, tcon register. Now I have to start the timer, right? But from which count it has to start so that it can generate 20 microsecond delay, right? So for that I need to find out the count value, right? What is the count value, right? Count value is nothing but 12 divided by this oscillator frequency, which is nothing but 1 microsecond. 12 divided by 12, 1 microsecond, right? But here we have 20 microsecond. So the total value count will be 1 into 20, you will get 20 microsecond, right? 20 microsecond. The hexadecimal value will be 14H for that 20, right? So now we have to find out the count value. We have already seen what is the formula for it, right? So FFFFH minus 14 plus 1, it will give you this particular value. And now we know that this is the lower bit, right? And this is the higher bit. So I have to configure TL0. We know that we are going to use timer 0. Now I am going to use TL0. What is the value? I am going to use ECH, and similarly TH0. What I am going to use? I am going to use f of h, right? That is what given here, right? Now you understand how is that we are configuring the tmod tcon register, how is that we are feeding the count value. Now whatever I have explained in theory, I am going to write it as a program here, right? You can see here, you know that I am going to use mode timer 0, so I am going to use mode 1 in timer 0. So I have to configure tmod, I'm going to use this particular value, right? You can see here I have used the same value. So I'm using the immediate addressing. This value will be fed into tmod, so that the tmod will be configured for mode 1 and timer 0, right? And now what I have to do, I have to feed the count value, right? What is the count value? You can see here TL0 ECH and TH0 FFH, right? So now TL0 ECH and TH0 FFH, I will feed this value. So timer 0 will be fed with this particular value, which is FFEC, right? This value will be stored. Now the value is stored, the timer is selected. Now what I have to do, I have to start the timer. When I can start the timer? When this bit becomes 1, right? This bit becomes 1, I can start the timer. This is the starting value, right? So I can start the timer, right? Now what it has to do, when we have to start the timer, we have to generate 20 microsecond. You have to generate 20 microsecond delay, right? Now the timer has started. We have given the count value already, right? So till 20, right, it will be creating that delay, right? It will be performing this operation. It will create that delay of 20 microseconds. How it will do, right? We can see here tcon register. What will happen right now, whenever the timer overflow happens, that is we are using timer 0, that is TR0. So whenever overflow happens, what will happen? TF0, this particular flag will be set to 1, right? Whenever this set to 1, the timer operation will be stopped, correct? Right? Because it will be, the interrupt flag is enabled here, right? Now until it becomes 1, what I have to do is it has to perform the same looping operation. That is what done here. You can see here, jump if no bit. That is this. You can see here, jump if no bit. It will go to this particular label. It will keep jumping if this bit is not set. If this bit is not set in the sense that has to be 0, correct? If it is not set, it will be keep looping, jumping to the same particular location, right? Which is tcon.5. What is tcon.5? You can see here 0, 1, 2, 3, 4, 5. This is tcon5, which is TF flag, right? So until the TF flag becomes 1, until the interrupt becomes 1, right, it will be keep on looping in the same step. And when it becomes 1, what will happen? It will not jump, because jump if not bit, right? It is set here. If it is set, then it will ignore this and go to the next one. Next one is, you can see that this is, we have already created the delay. Now we are seeing the next operation, which is send logic 1 to port 2.0, that pin. That is, we got to enable that pin. So set B, I am enabling it, and now I am going to stop the timer, right? So now the operation is stopped, right? So this operation will be, we can continue this operation for further delays, right? So that is smart jump here, right? That is the end of the program, right? So this is the step which we have to follow, where for programming timer 8051, you have to select which timer, right? First you have to determine whether I'm going to operate in timer mode or counter mode. Then I have to decide whether which timer I have to use, and then you have to configure tmod and tcon register, and then you have to find out the count value, and after finding in the count value, you have to load it in lower bit and higher bit, and you can write the program. Clear? Any doubts here? Right? So I believe this video will be very useful for you, right? So today what we have seen is, we have seen the timer programming in 8051, right? So we have seen the basic information about the timer programming, and then I have explained one particular program about creating a delay, right? Thank you, my dear students.
Thank you, students. Thank you for watching. கண்டிப்பாக இந்த வீடியோ உங்களுக்கு எல்லாருக்கும் ரொம்ப யூஸ்ஃபுல்லாக இருக்கும்னு நம்புகிறேன். Subscribe Passionate Professor and keep learning. Thank you very much.